Hello and welcome to the sixth video of this DSA problem solving series. In this video, we'll look at a question of this abstract data type known as queues. And I'll tell you what the question is. The question is an implementation based question, is similar to the design questions which Leetcode has a plethora of. And the reason why I chose this implementation based question is because a lot of times in interviews, the interviewer asks us to implement the functions which are already given in STL. Sorry. So what they expect is for us is to not use the functions already provided in the standard template library, and they want us to implement the function. So it becomes important that we have a keen eye on these implementations as well. And when we're asked to implement these functions, when we're asked to code these functions, then we do it in a very systematic manner. We create classes and then we have functions. So Leetcode has already provided this template which we have to edit. Otherwise, it's very important that we use that template in our real interview as well. So let's hop on to the question. Okay, so this is the question: design a circular queue. So let's give it a read. Design your implementation of the circular queue. The circular queue is a linear data structure in which the operations are performed based on FIFO, first in, first out principle, and the last position is connected back to the first position to make a circle. It's also called a ring buffer. One of the benefits of the circular queue is that we can make use of the spaces in front of the queue. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in front of queue. We'll discuss all of these when we go on board. So this is the class and these are the functions. This my circular queue function will initiate a queue with size k, and then front will get the front element, rear will get the rear element, NQ will insert an element, EQ will pop out an element, is empty will return if the queue is empty or not, and likewise is full will return if the queue is full or not. Also, what's important in this question is what we need to return if some of the constraints are not fulfilled. For example, for front, if the queue is empty, we'll have to return -1. Same goes for rear. Uh, and then we'll have to check another conditions whether we can insert the element in the queue or not. Because if it's full, then we can't insert, and likewise for DQ, if it's empty, we can't pop out the element. And another important aspect of this question, I'm sorry, of this problem is this constraint that the value of k, it should be less than 1,000. So that is also an important aspect of this question, because it's not a very huge number. We can utilize this when we share our memory while solving the problem. So let's hop on to the board to understand what this circular queue is. Okay, so let's understand what a circular queue is. Let's see first what a queue is. So in a queue we have two pointers. One is where it starts from -1 and then it's front. And it starts from 0. And how we implement any queue is whenever we insert an element or whenever we enqueue, whenever we enqueue an element, we add one element to the layer. So there will point to 0, and then whatever that element is, it's a 3. So that's how we enqueue an element. So let us fill this queue forward. So in this situation, this will be the layer and this will be the front. So here, let's say if I have to dequeue an element, what do we do here? We simply forward the front pointer by 1. So front was pointing here. That's it. We do not do anything to this element, because what is RQ? RQ is not this complete array or this complete vector. RQ is whatever there is between front and rear. That is RQ. So RQ will become elements in RQ will become 4, 5, 6. It doesn't matter what is here. So let us add some more elements. Let's say 7, 8, 9. Let's say that. Here, and these are the elements. And let us dequeue. Let us pop out some of the elements. So let's say DQ5, DQ6. So front will be here, right? So what will be the size of our queue? It will be 3, 1, 3. And we have popped out all of these elements, these elements will exist for us. Now what happens if we do NQ, let's say 0? We need to insert 0 in this queue. But we cannot, there is no space. There is the task position. We cannot NQ 0. And this is precisely what the problem is with a simple queue, that even though all of these places should be available, because we have popped out all of these elements, we do not need them, but it is not available in a simple queue. So we are effectively using less than half of our memory here. So that's the problem, and that's why we design a circular queue. What happens in circular queue? Let's see. So this is the condition. Here we NQ0. So what we do is we do not just increase rear by 1 and then say, oh my god, the value of rear is greater than the size of the array, and hence we cannot do it. What we do is rear equals rear plus 1 percentage of n. What is this? N is what? N is the size of this thing, so it will be 3, 3, 6, and 7. So whenever we increase front, or we increment front or we increment rear, we do not just do front equals front plus 1. No, sir. We do front equals front plus 1 modulo n. So what happens? Let's say front was 0 initially. Then if we have to increment, rear was -1 initially. Okay. So we pushed an element, we included an element. So what would rear become? -1 plus 1 modulo 7, 0 modulo 7, 0. So rear was 0. Again, if we have pushed another element, then what will it become? 0 plus 1 modulo 7. What that? Now see this condition, this is the situation, and then as you saw, we have to include 0. Rear is at 6 here. 6. So now what will rear become? Rear will become 6 plus 1, 7, which is 7 modulo 7, which is 0. So rear will start pointing here, and we will insert the element 0. And let's say if we have to include another element, let's say I have to include 8. So what do? Rear is 0. We do 0 plus 1 modulo 7, the answer is 1. Here points out here. And then very easy. In this way, we can use all of these space available for our queue, and we can insert elements and then pop them on and then insert them again without having a loss of memory. Now, what will be our queue? This will be our queue, right? 8, 5, 6, 7. Now, queue, as I said before, also always start from front and ends at rear. So here, the queue becomes this. This is our queue. 7, 8, 9, 7, 8. And these are again deleted elements, popped out elements. This is why this is called a circular queue, because it goes around in circles. That's why the name. So I hope the concept is clear. There is no as such approach to the code, so we just directly jump to our Leetcode window. Okay, so let us just begin with our code here. So we'll have to have a global variable so we can access this k from any variable, and we will make a vector array of size. Is it less than or equal to 1000? This why we are doing an understand, and obviously we initialize 2 pointers. So front will be initialized to 0 as we saw, and rear will be initialized to -1 as we saw. Okay, so the first one is Boolean NQ. We have to insert an element. So first of all, what is the constraint here? The constraint is if when can we not insert an element in this scenario? When can we not insert an element? So we'll write the constraint later. Later, let's first write what happens. So if we insert an element, we have always inserted an element from there. So there will become there plus one. N, because n is k here, and we do array of here. And we return false here. So this is the false constraint. Sorry, is that if we need. Okay. So when do we return false here? So that is the constraint here, that we have to have another integer variable initialized, and every time any element is added, we just do this. And now it becomes very easy. If x is equal n, then we say return false, we have no space. Right? Similarly in dq, if x equals 0, say return false. Else what we will do is remove friend plus modulo n, x minus not have to insert any value because it's dq. Okay, friend. So when do we, what do we do if friend is equal to 1? I'm sorry, 0. That's where it started from. So that means that no other element has been added. So sorry, else we simply return. Easy, right? Same goes for where if there is equals for full, if x is equals n, we say return true, else we return. Okay, so yeah, that was that question. The entire point of doing this question is because this template is very important. That's what makes our code clean. So whenever we are told to implement a function or a data type on our own, it's a very good practice if we do it in this method. We initialize a class, we have private variables, we have public variables. So the code looks clean, and yeah, that's why this question. That's why I chose this question. Hope you learned something in this video. Thank you very much for watching.